Welcome to Ron's Holiday Lights. Today we're going to do Hello World for an FPGA. This basically consists of flashing an LED. The board we're going to use is a Cyclone 2 board that you can get off eBay for $15, $16 shipped. If you look at the board in the bottom right hand corner, there's three little LEDs down there. And what we're going to do is blink those. We're actually going to count backwards, since when the signal's high, the LEDs will be off. This has two programming ports, one active serial and one JTAG. I recommend that we use Quartus version 9.1. This is probably the easiest version to use. There are later versions, but they require more knowledge to use them effectively. So the first thing we need to do is go up to File and say New Project Wizard. Click Next and then pick the directory that you want to put all your files in for the project. For us, we'll pick a directory called Hello. Once you have the directory, open it and pick a name, and again we'll say hello. And this would be the top entity for the design. If you have files that you want to add or libraries, you can add them at this part. We'll just click Next. And then you select the part. We'll pick a Cyclone 2. It's a quad flat pack with 144 pins. And I believe it's the slowest part. And then click Finished. That will create your top entity for your design, Hello. So Altera allows you to both use text-based files and graphic files. We'll open up a graphic file and save it as Hello. This will be the top file for our project. So there's a couple things we need to do first. Under Project, under Assignment Settings, we need to pick the Timing Analysis setting. I recommend using the classic timing analyzer. TimeQuest is a lot more difficult to use, and you need to understand quite a few things to make that work well. Also, under Settings for Device, we want to pick the default for the unused pins. Altera defaults to output as driving ground. I prefer the input tri-stated with a weak pull-up. That way if you have something driving the pin, it's fine. Or if it's an output, it's fine because there's a weak pull-up. So if you double-click on the space on the drawing, it'll bring up the Mega plugin wizard. And as you can see, there's a lot of different functions you can select from. We'll pick to create a new Mega function, and we'll name it Count 28, because we'll use 28 D flip-flops or count in binary up to 28. And you can see all the arithmetic functions. We're going to just pick the counter. Once we've selected the counter, we can go on to Next and pick the characteristics for the counter. We'll pick 28 bits. We can pick count enables, carry ins and outs, and a lot of things, but we'll just leave it as a plain binary counter. Okay. And once we're done, it'll bring up the symbol and we can drop it on the sheet. The next thing we need are the inputs and outputs. So you can type them in if you know what they're named. We'll type in input, put it in for the clock input. The clock input to the FPGA board is actually a 50 megahertz oscillator. The outputs, we'll need 3 of them for the LEDs. So you don't have to physically connect the pins, you just have to match the names. So on the output there's actually 28 binary outputs, and we'll name them Q27 down to 0. And then we need to connect them up to the 3 outputs for the LED. But first I'm going to change the clock input to 50 meg. So we have to have a big enough counter to divide that down so we can see the LEDs flash. So here we're drawing connecting lines. The dark one is a bus, the light lines are a single line, and we'll label the outputs Q25 through 27, which is the last 3 outputs of the counter. And then we'll pick the output names and we'll name them LED 1 through 3. Now the LEDs are turned on asserted low or at a low voltage, so our counter will actually count down. Then we go up to processing and say start compilation. This will compile our file, make the net list, and create the programming files. And this shouldn't take too long since it's a small file. If you notice, the screen will show you how many resources within the FPGA you're using for this design. Now that we have a completed project, I'd like to simulate it. So what we'll do is we'll go under File, say New, and we want a vector waveform file. This will bring up a blank page which we'll save as hello. So you can save one for each page of your design. If you clicked on the space and click Node Finder, it'll show all the I/O pins, and we'll bring them over and put them in the design for simulation. For the clock, we'll set it at a 50 megahertz clock, which is a 20 nanosecond cycle. One more thing I'd like to do is under Node Finder, we can actually search for registers post-fitting or design entry names. They all work. And if you notice it brings up all the outputs. The top one actually has multiple registers shown, which is all 28 bits. So we'll copy that one over and it'll come in as buried logic. So we'll pick an end time of 10 microseconds. It's probably not long enough to allow us to see in the LED cycle, but we can at least see the counter counting up. So also I like to check and make sure that under assignment settings that the simulator has picked the correct file. This isn't always the case. So we'll go under processing and say start simulation. And this doesn't take very long to run since it's fairly short. And you can see it creates a new simulation report, and you can see the counter counting up, but none of the LEDs are toggling since it's only 10 microseconds long. But you can see that the counter is counting up. And on the properties for each of the outputs, you can make it binary, signed decimal, unsigned decimal, ASCII, whatever you need for your simulation. So if you select the simulation report and double click on it, you can copy it over into your vector file, which drives the simulation. So I'm going to change the end time to something a little bit longer to see if we can get the LEDs to toggle. 1,000 microseconds is a millisecond, and that's probably not long enough either. And I don't really recommend doing long simulations because they do take quite a long time to run. So we'll see how long this takes. It's a fairly simple design, so it shouldn't take too horribly long. So you can see it finished, and we'll scroll over, and it didn't count up even anywhere close high enough to show the LEDs toggling. So what we need to do before we program our device is select the pinouts. So I previously figured out what the pinouts are for each of the pins. The clock, you just type in the pin number. It's pin 17, and the LEDs are pin 3, pin 7, and pin 9. So we'll have to recompile it so it put those outputs to the correct pins. Once you got the compilation done, so now we'll go up under Tools, Programmer, and open up the Programmer. So need to make sure it's on JTAG. Once it's on JTAG, you can select the SOF file. And what this does through JTAG is just program the internal memory of the FPGA. If you actually want to program the external flash memory, you have to do an interact JTAG programming file. The other way you can program the board is as active serial programming. On this particular board, there is a secondary port that hooks directly up to the flash memory, and that's a POF. But we're going to use the SOF, and we're going to program our board. Once the board is programmed, since we're just programming the internal memory, we don't need to cycle power. And as you can see, the LEDs are counting down. And this is our Hello World demonstration for designing with FPGAs.